You come home after a long day of school to figure out how you failed a chemistry test on things you thought you knew well. After all, the test was on the different types of bonding, like ionic, covalent, and metallic bonds. You check to see what Mrs. Nielsen marked you off on, and you see words like polar and nonpolar. You don't know these words, but you realize that you've heard them before. Then you remember your habit of not listening to Miss Nielsen's lectures and how you've skipped all of Dr. Anderson's videos for the past few weeks. You realize that you need to retrain your brain in order to make this up. Generally speaking, yes, there are three types of chemical bonds: ionic, covalent, and metallic. But if you take a closer look at specifically covalent bonds, something odd happens. It might look like both of these molecules are similar, but if you take multiple instantaneous snapshots of these molecules, you'll notice that one molecule has an uneven distribution of electrons, while the other has equal numbers of electrons on each side. They are both covalent bonds, but their differences in electronegativity are the reason why they are polar and nonpolar. You've already learned what electronegativity is from Unit 3, but as a quick refresher, electronegativity is the tendency of an atom to attract electrons. The stronger the electronegativity, the more the atom hogs the electrons in a covalently bound molecule. You can usually determine electronegativity in two ways. The first is using a periodic table where electronegativity is greater as you move down a period and up a group. The other method is using the acronym Fonkelbrish, which shows commonly used elements in decreasing electronegativity. Like I said, the difference in polarity between molecules is found within their differences in electronegativities. Let's take a closer look at the polar molecule first. If you take a look at hydrochloric acid, you'll notice that the chlorine is much more electronegative than the hydrogen. Therefore, the electrons tend to be by the chlorine. In order to demonstrate this uneven distribution of electrons, scientists draw what's called a dipole moment, which is an arrow pointing in the direction of the more electronegative atom. The side with more electrons obtains a partial negative, as shown by the negative delta symbol, and the side with fewer electrons gets a partial positive, as shown by the positive delta. On the other hand, if you look at a nonpolar covalent bond, such as chlorine gas, you'll notice that the electrons are evenly distributed between the two atoms because they have similar electronegativity values. You think that this is all great stuff, and that conceptually you understand the differences between polar and nonpolar bonds. However, you know that you're more of a quantitative guy. Luckily, there is a way to quantitatively determine polarity. This can be achieved using the Pauling scale of electronegativity. This scale assigns each element a number between 0 to 4, 0 being completely inert to 4 being extremely electronegative. With that, you can find the differences in electronegativity by subtracting the electronegativity values of each atom within a molecule. If the difference of electronegativity is between 0 and 0.5, the molecule is nonpolar. If it's between 0.5 and roughly 1.7, it's polar. Anything more than 1.7 is ionic. Now you know the basic differences between polar covalent and nonpolar covalent molecules. Polar and nonpolar molecules have several unique properties which you can learn more about through other videos on Mrs. Nielsen's Chemistry YouTube playlist. You can now safely proceed and ace that midterm.